In section 7.3, we're going to look at finding the area between two curves. As we saw in section 7.4, a definite integral will give me the area between a curve and the x-axis. But what if we have another function? So here we've got f and g as our two generic functions, and we're integrating from a to b. Now, our general definition, this f function must be the greater function. It has to be higher up because it's very important to have the top function minus the bottom function. With subtraction, the order does matter. Here's where our calculator is really going to come in handy though. In our calculator, we're going to go ahead and put absolute value signs around this. That means that if we get these in the wrong order, that won't matter. It will also mean that with our last example, where these two flip-flop halfway, once again, we will not have to worry about it because the absolute value means we can just type it in. All right, should be a little F in there. So here we've got our two functions and the two bounds. So let's put in our bounds. We're going from -1 to 2. Now I'm going to put those absolute value signs in right away because I'm planning to use my calculator. So that means it does not matter which function I type in first. And then we've got dx. Now this first set of parentheses you don't need. I'm just putting it in there so you can see the f. The second set we do need though because we are subtracting. Now if you want to distribute and then put it in your calculator, that is perfectly okay. But be careful, if you don't distribute, you will need those parentheses. So let's get our calculator up and see how to type this in. So I'm going to go to math, and again we went to fn in for the integral. And let's put in our bounds. Now as soon as we're in here, I need to have the absolute value sign. To get to absolute value, I'm going to once again go to the math menu. And then I'm going to go right to where it says num. We've got a little sub-menu here. And that very first option, ABS, that is our absolute value. And you can see those absolute value signs in there. So -x² plus 1 minus, and I am going to put parentheses in here, 2x plus 4. Now I always encourage you, before you hit enter, double check and make sure we've got that typed in correctly. Since if we mistype it, we will get the wrong answer. But that does look like what I want. So let's hit enter. And it looks like I get 15 as my answer. So again, in this class, I'm not going to worry too much about setting them up by hand. Again, I'm just going to put those absolute value signs in and let my calculator help me out. Now, roughly half of our homework problems, we will be given bounds. And obviously, if we're given bounds, we'll go ahead and use those. However, we will have questions like examples 2 and 3 where we are not given bounds. So the first thing we need to do then is to find the bounds. Let's start by doing it by hand. So since we're not given bounds, that means these graphs intersect. So where they intersect, that's where they will be equal to each other. So basically we are solving that. Now this is a type of problem we haven't really ever solved before. What I want to notice here is this is a problem where we have x to 1 power on the left and x to some other power on the right. And we do want to note here that they are not both even. One is even, one is odd, or both are odd, but they're not both even. Needless to say, if you have that type of problem, so again, x to 1 power equals x to some other power and nothing else, that means our two bounds will be 0 and 1. Because 0 to any power is 0, and 1 to any power is 1. Now we can also use our calculators to help us out. So if you're having trouble finding the bounds, let's graph those two functions. So let's graph x to the 1/2 power, and then x cubed. Oops, cubed. There we go. Make sure I've got it typed in correctly. And let's hit graph to see what that looks like. Now we're going from 0 to 1, so obviously it's not a very big area. You can hopefully see it there. It's quite small. Now you might be able to see from the graph, but like with this one, if it's a small area, it might be hard to see. So I'm going to go to my table. So to access the table, I'm going to hit second and then graph. What I'm looking for are places where the y values are the same. Because if the y values are the same, that's where they intersect. So as you can hopefully see here, we have the same y value when x is 0, and then we have the same y value at x is 1. We don't care what those y values are, just that they are the same. So again, if you are having trouble finding those bounds by hand, use your calculator, and again, look to see where are those two y values the same. All right, so we are integrating from 0 to 1. So again, I'm going to put my absolute value signs in here so I don't have to care about which one's bigger and which one's smaller. And that's what I'd like to integrate. So once again, let's use our calculator to help us get that. So let's go to Math, FNint. My bounds are 0 and 1. And I am integrating x to the 1/2 power. My calculator keeps moving here, I apologize. Minus x cubed dx. Oops, I forgot my absolute value signs. So again, that's in Math. And then I go to num. There we go. Now let's type in x to the 1/2 power minus x cubed. There we go. Now it looks correct. Again, definitely double check. It is easy to mistype these. And now this one, it's a little bit messy, but we do get approximately 0.417. Again, for this class, we are going to be totally fine with leaving our answers as decimals. All right, let's do one more example. So once again, here I do not have bounds, so I need to be given those bounds, or I need to find them. So let's set the two equations equal. Now I can't use the same trick as last time because I have a constant out in front. To solve this, I'm going to take both terms on the same side, at which point I can factor out an x. And x squared minus 4, that does factor as well. That's x plus 2 and x minus 2. So here I've actually got three solutions. I've got -2, 0, and +2. I wrote those from smallest to largest. Now again, we can use our graphing calculators to help us out. So on the calculator, let's graph those two functions. So there's 4x, and we can hopefully see now there are indeed three intersections. And again, I can use that table. And again, here at -2, they're all the same. At 0, they're all the same. And then at +2, the y values are the same. So again, I can get those by hand or on my calculator. Now, these two graphs cross in the middle. But this is again where that absolute value is going to come in handy. With the absolute value, I won't have to worry about that. However, I can't put in 3 bounds. I can only put in 2 bounds. So anytime you get 3 bounds, we're going to ignore the middle bound. So we're going to take just the lowest and then just the highest. So here, we're going to integrate from -2 to 2. Again, the lowest and highest. And then, as long as we have those absolute value signs in there, we should be good to go. So on our calculators, let's go to Math, FNint, from -2 to 2. And let's make sure I remember my absolute value sign this time, of 4x minus x cubed. And then my dx on the outside. Again, double check to make sure I've got that entered correctly. And I get out 8 for this one. So this is about as hard as we'll get, where again, we have to find bounds, and it turns out there's 3 intersections. Again, when that happens, take just the smallest and the largest as your 2 bounds. And this is everything in section 7.5.